So as we always do, we start with this chart, market opportunity. We still believe very clearly in this chart. This chart essentially leaves us right now still in the fairly flat part down between 47 and 175 zettabytes actually out there of global data created. And remember, the whole idea of our project, the whole reason we exist, is because we believe in that upward part of the chart. We're talking about what we believe to be a great opportunity, and we're really at the very front end. We're still very early on it, and the key is to get this thing out there, get market share established with a very large network, a very performant network, and so forth. Starting out with a little bit of history, just to kind of give everybody a bit of an understanding. We forked another project's blockchain to begin, but we didn't actually fork everything. What we did is we forked the blockchain infrastructure, we forked some of the things like the difficulty adjustment algorithm, and ultimately, though, we started over from Genesis. We started over from scratch. We started off with a couple of petahash of hash rate, which is significant and pretty much satisfied us that we could make a go of this. We thought there was a pretty good chance we were going to get a lot more hash rate than that because there is a lot more out there, or was at least at that time, of devices. But what ended up happening was a little bit of subterfuge and some other stuff that happens typically when forks happen. And ultimately, we settled in and recognized that we were going to have to be here for the long haul. That was October 31st, 2018, and the Genesis block went off without a hitch. We had no issues in the beginning into 2019 and so forth. At that point, we were still a team of people working without any financial capitalization. It was nothing more than just a labor of love to piece it together. We were building white papers and plans and trying to get capital. And then ultimately in December of 2019, we did finally get the very first drops of capitalization for the project. And that allowed us to begin to start actually moving forward. 2020, we began to really move the project forward hard. We had released our white paper. We had gotten the information out there behind what we planned to build. And we also talked about in mid 2020 about actually creating a device that we would actually put out on the network. So we had a pretty good fleshed in plan. We had a reasonably decent team at that point, but we were following our roadmap, and that was the key. And if you recall, the two key towers that we always hung our hat on with the roadmap was metadata into a database architecture. That was a key one. And then also this idea called tokening, which took the asymmetric out of the whole contract process and made it so that you could actually scale. Okay, so what drove us was this whole notion of centralized data center zones, this idea that a couple of companies, in this case Microsoft and Amazon, have these local regional data centers, these big data centers, and essentially all of the data in the world is housed in these locations. If you want to bring down significant parts of the internet, if you want to bring down significant challenges in terms of security, it's pretty easy to do when all of the data is aggregated in these small regional clusters. You get one big internet backbone situation going down, and all of a sudden you have a whole lot of data that's inaccessible and not readily available to the client. So when you start talking about Amazon and the people that are looking at 11 nines of durability, they have some real challenging things, because what they're saying is they're saying 11 nines, but the math just doesn't work out. Because what happens is you upload a full copy of your data to the data center, and then they turn around and replicate your data, in other words, duplicate it in situ, the whole thing, and send it off to two more data centers. So essentially their idea of redundancy is send it to 3 locations, and then how they get to 11 nines is they say, in those locations, we're going to use erasure coding, and we will go ahead and split your data into a bunch of chunks inside of our 3 locations. When they talk about 11 nines of durability, or when they talk about their security and availability, they're really not telling you the whole story. And at the end of the day, it results in every single month or whatever, seeing in the news data center hacks, breaches, uh, websites down, network connections unavailable, and so forth. With this distributed data center, what would happen is everybody around the globe would own the data center. We would send out data to everybody's domicile, businesses, franchises, you name it. Wherever there's human beings and an internet connection, there rests the ability to house a piece of the distributed data center. And by sharding the data off and sending it out to all of these locations, we bring data closer to the people that are actually going to be accessing it. We make it more secure and redundant because essentially when we say we're doing erasure coding to send the data off so that 40 pieces can fail before your whole data set is inaccessible, we really mean it. Right now, when you upload your data to one of those two places, or GCP, or Wasabi, or Backblaze, or any of these others, they have a full copy of your data. In the distributed data center, we had to have a way to access all of the data on the network in such a way that it didn't have to actually come through a centralized facility. In our case, it just doesn't matter. The customer owns the data. When we decided we were going to build a node for this network, we decided to make it a 4-bay NAS style device. We'll talk about this in KPIs in a minute, but at the end of the day, this device has turned out to be just a real hit with the network and growing it out and making it consistent across the board. We've already signed up 3 different manufacturer partners. These partners have built hardware and are waiting for us to give them a software ISO so that they can load it on their own devices. And pretty soon you're going to be able to buy an Examiner from 4 different places. So our thing is we wanted to start it out with a really consistent device. We succeeded with the Examiner. There are over 1,000 of them actually live on the network right now, serving up over 45 petabytes of data, and it's proved to be a real success for us. But in the renter-host protocol, what you're talking about is renter on one side, host on another side, and the ability to have them communicate via a smart contract that does away with lawyers, bankers, accountants, and cross-border friction. This device, the Examiner, is the actual host in the renter-host protocol. Okay, we're going to now turn it over to our wonderful friend Henry, and he's going to take you through a demo of the Examiner, because if you don't have an Examiner, or you haven't bought one, or you haven't actually checked into yours lately, you would be surprised if you did check in, because we've kind of made a new interface for it. We're rolling in a bunch of features, and if you're keeping an eye, version 1.1 will be hitting your device very shortly. Take it away, Henry.
Yeah, that's exactly right, Ken. Thank you very much for the intro. We'll go over quickly a kind of overview of the Examiner device. I know some of the people watching this will have these and are pretty familiar with this, but we'll cover the basics first. So the Examiner is that hardware node that we discussed earlier. So these are what stores the data when it's at rest. These have 4 hard drives in them, and these receive passive income in the form of blockchain contracts for storing data that is uploaded to it by customers. So the Examiner itself, all it needs plugged into it is power and Ethernet. You can access it over the local network, so we call that headless. So this is an example of an Examiner that is accessed over the local network. You can see it up here. This is my actual Examiner, by the way. It has been online for 364 days, very nearly a year, and it's done quite well in that time. So this is the web UI. This is how you access it. This is how you check on it. This is kind of the hub for seeing everything Examiner. In this web UI, we have the financials tab. So this gives us all the important information like our wallet, the ability to send and receive coins. It gives us visibility in our contracts, which we'll come back to in a second. It gives us some estimates about income and our rebate schedule as well. So we can see I've received 3 of my 4 rebates. I should get the final one tomorrow. And then as we scroll down a bit, we have some information about how the Examiner itself is operating. We can see the ports that it's using, different software versions, and so on. Lastly, down here we have our transactions. So this is kind of blockchain language. A lot of it might not make a ton of sense if you're not already well acquainted in the space, but this transaction ID, this gives you information that you can then look on an Explorer to be able to see the specifics of what's happening, where coins are moving, why they're moving, when that happens, all that sort of information. And there's an extensive pages history of all the movements in and out of the wallet. So back to contracts. So contracts are what is formed between the renter and the host in the protocol. So your X miner you can expect to have at least one or two contracts. Those contracts will most likely be with us since we are conducing the payments between the renter and the host. So if you open the contract browser, this will take just a second because I do have one of the older X miners and it has quite a number of contracts in its history. But we can see here a full log of all the contracts that this X miner has ever been part of. We can see the size, the length of the contract, the time period, all that sort of information that you might want to see. So this is a really good way to provide visibility into what's actually going on. And then there's also an alternate view where you can see a timeline explorer of kind of stacking one on top of the other, the length of the contracts, how they completed. So we can see up to today, I have one very large contract still active, and then there's a couple smaller ones in there as well. But we can see that my X miner has a decent amount of utilization, which we can see if I hop over to the stats page. So this is using a service called Grafana. This is how we serve the kind of network dashboard. This should be accessible from anywhere. So if you're not on your local network, you can just click open in Grafana, and this will serve you a web page that will report some status of your miner. But it's available right in the web UI as well. It'll give you some of your uptime, your usage capacity. It'll give you some of the rates of storage, network usage as well, your disk temperatures, all the sorts of things that you would want to see if you're just checking in on how your X miner is doing. And if you scroll down as well, there is sometimes the advanced tabs. You can see some more advanced information, but right now this dashboard is coming together pretty well and is very useful for checking in your X miner. If you're not necessarily on your home network, then you can see how it's doing from anywhere. We also have a settings tab, which includes at the moment just these 4 settings. So for the most part, we expect X miners will want to choose auto pricing. So that's where the pricing for different things is fixed to a US dollar amount, and it just adjusts the coin price to reflect, or it adjusts its pricing in terms of coins to reflect the volatility up and down of the coins. So that's what you're seeing here. But if you wanted to, you could override, for example, the download bandwidth. And there is also a support tab as well. So this is something that includes some information for how to get started with the Examiner and receive support as well. There's some buttons here for things like downloading logs, which may be useful for troubleshooting. There's re-announcing, which can be useful in certain circumstances. So this is kind of the support page, probably not something you'll visit a ton, but when you need it, it is very useful and straightforward to do a lot of common actions with it. There is also, as we alluded to earlier in the top right, there is the ability to see updates when they're available. You can either have that automatically update on your unit, or you can choose to manually do that. But either way, if you click up here, it'll tell you when one is available. There's also the power button, so you can restart or power off. So that way, with your Examiner, you can achieve everything that you need to do with it without needing to actually be physically plugged into the unit. You can achieve everything with the web UI and check on the status of it. So once again, this is an Examiner that I've had for about 12 months, and it's doing fairly well, I'd say. I'd imagine some of you are maybe looking at the wallet balance. So that is a number that I haven't deposited nor withdrawn on this Examiner in the almost 12 months that I've had it. Just out of curiosity, I've kind of wanted to see how it accumulates coins over time, and without complicating that by putting coins on or off the miner. So just as a bit of an experiment, you can see that I've had this one for about 12 months and I have about 5,700 coins. But tomorrow, when I do receive that additional rebate, then that number should be a bit higher as well. Since my X miner, I have taken the care to ensure that it has above 95% uh, uptime, so the condition is satisfied. So this one is a pretty well functioning, happy X miner.
And how long has that unit been up online for? Tracked since August 21st, 2021. So almost exactly 1 year. That's pretty awesome. So one of the things that I think is interesting here is that a lot of people right now are wondering about, how did the people get all this, data on their units and how did they get the numbers that they got and so forth. And it really is a function of time. I guarantee that the people that are here a year from their current inception date, if they started here in 2022, are going to be having the same kinds of conversations as what you're having right now. How do you feel about that, Henry?
Yeah, I think that's exactly right. I know when I picked up my X miner, one of the considerations that I was making is whether I should buy just SCP coins or whether I should buy an examiner. And my rationale to myself was that by buying an examiner, I knew I would be receiving those rebates, which would bring a considerable amount of coin back, and I would be earning those SCP coins over time. So I figured that it would be a good way to still accumulate coins with time. And I know that in the future years, I mean, if this is how it's performed over 1 year, and that's with generally little utilization of the network, I'm pretty excited for years 2 through 5 and beyond, where this thing will be absolutely sucking down coins and being very productive for me.
Beautiful. Let's continue on with our overview of something that we're calling the distributed data center. That is the whole agglomeration of providers being stitched together to look like a single homogeneous whole across the entire globe. And the beauty of it is that it doesn't matter where anybody lives or where people need to store data or where on the globe they are. As long as there's internet connectivity, we're going to be able to touch them. And so one of the things that happens when you look at a typical global map is you see a lot of dead zones when it comes to data center type things. And this is pretty typical when you start looking at first world versus, third world type environments, or even first world environments that just haven't really fully digitalized yet. So like South America is a pretty good example of this. When you go to looking at the data centers for South America, there's very little things there. And one of the things that I've always known about South America is that equipment that gets sold down there has a real hard time because they have really, really high taxes on their equipment that come into the countries. And I'm not talking about 20% VAT rates. I'm talking about really high, sometimes as much as double to get equipment down there. So you have all kinds of brokers and people that are bringing equipment down. And so what you end up with is you end up with this interesting sort of time lag. So I come from the video side of things, and it used to be that whenever broadcast would finish up with a model or, camera models that were being really heavily used in the film industry would get superseded by new models that were fancy and hot and new. What would always happen is the old models would then find their way down south, and they would get muled in through brokers and through freight forwarders and other ways to get them in with lower taxes. And then ultimately you would go down south and you'd find in South America that a lot of the facilities were one gen behind. And I don't look at that as any different. I think what you're going to find is that over time, we are going to show up in places like South America and Africa and places like the far eastern part of Eurasia and so forth, where the other data centers don't find it lucrative or useful or beneficial to stand up units. So what they end up doing is telling customers to accept the latency and send all of their data there. It's very easy for us to go into Facebook or Google and keyword and say, look, let's do a geo advertising campaign that targets this one little area of Myanmar and say, We need 100 or 1,000 or 10,000 providers in this region because we have a corporate customer who has a ton of data that they want to upload, and they want to have something very close, and they don't want to send it back to America or to Europe or wherever it could possibly go if they're going on Azure or AWS. So that's part and parcel of what we bring to the table with this distributed data center. If you're somebody that has a connection inside of a large franchised organization around the globe and you think you can get units into the back office of every McDonald's around the globe, for instance, we will be able to put together some kind of a configuration for you that will go back there very easily in an industrial environment, sit quietly and do nothing but just serve storage all day long. We also recognize that do-it-yourselfers, enthusiasts, and people that really want to put together their own configurations have this ability. So we've actually created a software application that mimics what you just saw there in the Examiner. We have it currently in alpha testing right now with the very first Linux trialers. It's working pretty good. I mean, it's got your normal alpha kinds of things that we're running into that we need to clean up. And then I think we'll be able to release beta next week. And then after that, we will give people the ability to go ahead and purchase, or if they've already purchased, to roll out their own examiners, so to speak, even these bespoke one-offs that will be able to be called examiners. And then over time, you'll be able to continue to buy those licenses to put onto as many miners as you want to roll. And we believe that that will continue to go hand in hand and side by side with the manufacturer built devices. And Scoreboard right now says we have the second largest network in crypto, and that means something. And if you don't think it means something, wait till people start uploading data. And we're focused entirely on business cloud using an industry embraced S3 protocol. That means there are thousands of applications out there already available that can be used on our network easily. Archival, media asset management, file sharing, cloud, whatever you want to use, there's likely an app already out there that you may already be using. You may have written something yourself that talks to the protocol, and ultimately you can throw that on to our network and move forward. VM, Commvault, we have already tested tons of different applications, and over the next 12 months, that will be a huge task for us to go through and find and qualify as many of them as possible, and to find any little wrinkles and kind of smooth them out as we go forward. Some of the KPIs that we look at for this network that we've built are the number of providers that exist on the network. Everybody that stays in the Discord and spends a lot of time there understands that what we've built is we built a network that went into exponential growth in December of 2021. And when we realized what was going on, we slammed the brakes on it. We said, look, we're only going to sell 1,000 examiners in this run. So if you didn't get in, you didn't get in. Sorry about that. Because we saw very clearly that we still had work to do on the software that we are providing and showing to you today. We could not say what I am saying to you today, that we have a complete end-to-end network that works. You can log in today, get storage on the network. It will go off to providers that you select, and ultimately with erasure coding ratios and durability math that you decide, and ultimately goes up onto the network. We can work with partners through subsidization, and we right now have about 3,800 providers providing about 75 petabytes of raw capacity for people to store on the network. And you can see over the last 10 months what the network use has actually been on that network. But you can also see that it's mirrored by the actual capacity that we threw onto the network last year. We have a very manageable network right now, but it is not going to be stayed and stasis. It's going to grow rapidly again over the next several months. Why? Because it can. Now we're at a point where when we go out and start finding partners that have customers to onboard, and somebody comes to us and says, look, we've got 100 terabytes or 2 petabytes or 20 petabytes or 50 petabytes, we can say, we can do that. We can handle that. And if they come to us and say, well, look, we have headquarters located in this place or that place or the other place, we can go out and get you more providers around your headquarters. What I'm going to go into next is I'm going to go into a little bit about this network. But before we get there, I want to talk a little bit about sort of what wraps this all together so that you can sort of understand the end-to-end nature. And we call this thing the console. And you've probably been exposed to the console now. Because what the console is the console is the place where you're going to log in if you're a partner, if you're a provider, if you're anybody who has any sort of connection onto the network. That's where you'll find all of your permissions and all of your assets. And when we first released it, people can remember that there were only like 3 links in it, right? There wasn't very much going on. Now what happens when you go into the console, you can see that we've started fleshing everything out. And before Henry takes off and gives us a good solid demo of the console and what's going on in here, I just want to kind of go over this notion of, partnering, onboarding, subsidization, what we're looking for, and then we'll talk about the console itself and how it's being used for billing and so forth, and what our goals are, what's working today, what's not working. You can go in and then purchase storage. You can then, view your account and your billing and all of the things that go along with it. But you can't provide any of that permissioning yet. You can't, have root account and then give group policies and provide that kind of access. That's the stuff that we'll be building out over the next 6 to 12 months. So today, to do it, what you would do is you'd use your standard internal networking. But see, because our thing lives on your network, on your site, that's really easy to do. If you're using Amazon, it's a lot more difficult because your data is uploaded to their facility. So you need those policies. Here, you can set them up on your own pretty easily. The other thing I want to go over real quickly before Henry gets into this is when we start talking about the relayer, people are having some concerns and questions because they say, well, I have this relayer in the console and it's like, in Northern Europe, but I've got a headquarters in Northern Europe and I've got one in California. And I don't understand how that works. I mean, can they talk to each other? Can they share data and so forth? And the answer is yes. We can set you up with the database metadata in such a way that they share the metadata of what's on the network. So if a relayer is in Europe uploading data into their cache and accessing the network, and a relayer is in California and uploading and accessing their cache, it is very trivially easy for us to tie those together so that ultimately you can have relayers everywhere. And you can even mimic things like content delivery networks that way. We'll get into more of that in a minute, but I'm going to turn it over to Henry now again to walk us through all of the pieces of the console, talk a little bit about the map, and take it a little bit further. Go ahead, Henry.
Yeah, thanks. That was a great introduction. So the console today, as alluded to earlier, probably many of you have already visited here for reasons that, well, the licensing we'll get into in a moment. But if you haven't seen this before, this is the home and kind of the center for your different interactions with controlling Examiner account information and relayers as well. Certainly, you'll be sure to visit here if you're running a relayer. So when you visit the console, you're dropped at this home page. So from here, we can see some network information at the top. You can see the 1,000 examiners that we alluded to earlier. But in total, there are close to 4,000 providers that are on the network that we use. And we can see the geographical distribution of them here as well. So one of the flaws of the map representing it in this way is that this looks like there's not that many different hubs, but you'll see when we zoom in, actually, these bubbles are just representations of densities of providers. So the red is like high density, yellow, medium, and blue is kind of low. So you can see if we zoom in on the Northeast, the further you zoom, the more it kind of breaks out because there are providers distributed all over the place. And that's the network today. This is before we've even expanded out to those different partner manufacturers. This is before we've heavily advertised. Things are already looking in such a way that almost anywhere you go across the United States, for example, or Canada as well, there's a very smooth distribution of examiners, and particularly focused at population centers. And Europe is certainly no different. Over here, as if we zoom in, specifically Netherlands, for example, has a very high concentration of providers, so lots of options in lots of different towns and cities around. You don't have to look too far to find a lot of good options and a lot of good providers for any geographical region. So this is something that's kind of fun to do, poke around the provider map, but I would certainly expect in the future as well some of these less dense regions as we start discussing with partners that are perhaps in those regions, and we gain incentive to push in certain regions. I would expect some of those areas to populate as well. So from there are a couple of different options along the side. So for example, for deploying a relayer, this is where you would get the download executable for a Windows relayer install, and the instructions as well for getting started on Linux. And it takes you straight to the documentation page, which is where you would start up your install, hopefully. We can see keys as well. I'm not going to open that for security reasons, but that's where you would see your different authentication keys. But in general, because of the way we've constructed the relayer and on the relayer application, which we'll get to later in this call, you actually log in with your console account. So although there are authentication keys, you generally don't have to work directly with them. Your console account is your authentication center. So there is also, well, if we had licenses, for example, on this particular account, we don't have any licenses registered, but if we had a homemade or homebrew storage provider and we were interested in providing storage on the network, this is where we would plug in our license. But that just isn't the case on this particular account. But if we head over to accounts and billing specifically, usage, you can see some of the history, for example, of different coupons that I've plugged in. This is where payments would be discovered and usage. This account hasn't been terribly active over the last 30 days or so. You can see it's been stuck around the same, just under 13 gigs, but you can see the balance evolution over time and how it spends those coins, or the balance as well. As we move over toward more network operations center, so this is a public dashboard. This is a display that we have enabled on everybody's account. So from here, you can see all sorts of different aspects of the network. We can see some of the provider stats that are, perhaps some of that information has already been elsewhere in this presentation, but we can see in real time with some historical trends, some of the different capacity, the network usage. You can see for the last 2 months or so, we've been on a pretty good upswing. We can see for example, the software versions that our different providers are running. So the vast majority of them and all of the X miners are on this latest version. We have some insight into different telemetrics as well. So this is something that we are happy to provide some visibility into publicly, but internally, we can do all sorts of neat things with, perhaps network throughput of all the examiners. So you could perhaps see when somebody is really pushing a big upload because the network goes well over like 200 or 300 megabytes a second, which is pretty impressive. And that's just over the last couple hours as well. During some real network tests, that number can be much larger. We can see trend lines for different disk temperatures and all sorts of things that are kind of interesting to see, and just give a bit of a taste of some of the insight on some of the internal tools that we can see, some of the big data and cool telemetrics that we have access to, both through relayers, which we'll get to in a bit, and examiners and some of the different network statistics that we can use internally, or we can provide access to a customer sort of thing. But that lives in the console today. We also have the docs tab. So this takes you to the relayer docs. So if you were to get started with a relayer, this would be a very good place to start reading. It gives you all sorts of a guide for what kind of hardware you might need to get started, some of the different considerations, some insight into how the relayer actually works and what it does. Yeah, and you may have noticed that there are some panels in this console as well that may not be on yours, perhaps on this admin access or the cloud. And that's because we feel the console is such a good tool that we internally use it for some of our processes. So not going to go into too much detail on that, but I think it's must be a good indication if the team is feeling good about the console and is building more of our internal processes into it. Then I think we can expect publicly that this will be a tool that is in a good place today and will only get improved from here on. Back to you, Ken.
One of the major features that we talk about a lot is cost and cost certainty. So yes, we do expect to disintermediate price, and we do expect to do it in a couple of unique and interesting ways. Some that you can see very clearly on the surface, and some that are going to give you a heck of an edge underneath if you're a partner or somebody who gets out there and decides to resell our storage. But it's going to take a little bit of homework and a little bit of expertise in order to do it today. And the relayers are extremely flexible. There's a dozen ways you can set up relayers that are going to be really wildly, available, accessible, secure, performant. Whatever your needs specifically are, you can typically find a way to configure a relayer to do what you want. So when we get back to cost and cost certainty, that allows us, this whole sort of process allows us to say things like, well, we're going to set a flat rate price, and live to it. When you set up Amazon or Azure or GCP or really any of the centralized clouds, you're not going to get that. You're going to get a charge. And then on the back end, they're going to say, well, yeah, but if you go over X, you're going to have to pay extra, or you're going to have to pay if you need certain kinds of availability. And ultimately, those are the charges that they love, because those are the charges that really balloon out the monthly bills. The other thing is that they're going to charge you for download. This is vendor lock-in. This is how they get you. They get you to upload 10 petabytes, which isn't going to take a short period of time. It's going to take a long time to upload 10 petabytes unless you do some kind of a manual upload and FedEx your data. What happens is once all that data is uploaded, if you want to take it back, you actually have to pay them to get your data back, which is something that we don't have. We do not have egress fees. The other thing, if you set up an application on those networks, and yes, you can set up applications on our networks. If you wanted to run Pokemon Go off our network, you can run it off our network. You could stand up whatever relayer configuration makes sense, and ultimately you will own all of that data. But we don't charge you for the API touches. Now, if you go out and look at even people in our space, you're going to see that those are charges that are starting to show up on their bills. And now here's a big one. And this is one I've never talked too much about, but ultimately it's going to come up and become a big thing. And if you want to look at your decentralized friends, quote unquote, to see what they're doing, ask them if they do this. So let's say you upload 100 terabytes. Well, what ends up happening if you upload 100 terabytes to AWS is 100 terabytes goes to Virginia or wherever. And then ultimately what they do is they take that 100T and they send it off to 2 other data centers. They don't charge you for that though, by the way. They eat the bandwidth to send it off to 2 other data centers, and they eat the storage to send it off there. That's what's bundled into their $23 a terabyte price. They say we have to upload this to a couple of places and we have to store it. So yeah, we charge you the money we charge you. On a distributed network, what we have the ability to do is using EC, erasure coding, we chunk and shard this data out in such a way that we can make it more durable by sending it out to more places. So if we send it out to 89, providers, and of those 89 pieces that are out there, let's say 39 of them are parity pieces, that means that 50 of the pieces are your data and 39 are actually redundant pieces. So what does that look like? Well, that 39 is the equivalent of when Amazon sends your data to data center number 2 or data center number 3. They don't charge you for that, and neither do we. We will charge you only for the 100 terabytes that you upload, and that will be it. So we do have a significant cost advantage over everybody, including people in our space. And then we get to what I think is probably going to be the biggest advantage we enjoy over everybody else, and that's environmental sustainability. What's happening right now is data centers are starting to get looked at harshly across the board and for every reason imaginable. They become utilities. They become essentially essential pieces of society. And if they go down, they cause enormous problems. The governments, the companies, the people's access that need them for various kinds of services and so forth. So what happens is you start to look at these data centers and you start to realize that these are awful environmentally footprinted installations. They take up big chunks of real estate to load up acres and acres of servers. These servers put off a ton of heat. And so because of that, they have to be specially cooled. And typically what ends up happening inside of a data center is that they have to actually have somewhere between 1.5 and 2 times the amount of equipment and energy and electric costs. And now what everybody's starting to understand, water. They need water. So how are you going to put a bunch of data centers in Africa if they need a bunch of water? What's going to end up happening is people are going to start to look at the unsustainability of the traditional data center model, and then they're going to start to look at the model that we've built where people are just standing up these little units that can run on a little 80 centimeter fan, and they don't take up any extra, energy for cooling. You plug them in, they run at, really inexpensive amounts at the wall just for the storage pretty much, and nothing else. And ultimately, we end up with a PUE factor that is as close to 1.0 or 1x as you're going to find. Businesses care. They have to file shareholder reports. Shareholder reports now have to have full ESG statements in them so that shareholders can feel comfortable that they're not supporting evil. And what happens is that entities like ourselves that can stand up very loudly and clearly and say, look, we are those guys, are going to get business that the other guys are going to lose. It's a big one. It's a real big one. And trust me on this, it will be one we headline all the way down the road. End-to-end encryption is something that we've always championed. All of the other services will allow unencrypted data up onto the network. They may make it standard now for you to encrypt on your side, but at the end, you literally cannot upload on our relayers without encrypting first. You own the data. It never leaves your facility until it goes to our network. But it never leaves your facility until it's encrypted either. And so, nobody ever has access to your data but you. We talked a little bit about our durability and how it's different. And then, of course, this proximity one is really interesting because it points out something that I think is really useful right now about how we're developing what we're developing. And that's, we're building an animal that nobody's ever really seen. I think the closest probable analogy right now to what we're building might be Cloudflare. And I've said this in the past because they're the biggest distributed node kind of organization around the planet that I can see right now. And what we're going to end up building when we get 100,000 providers out there and 20,000 relayers running against it is we're going to get a really good ability to understand what the big distributed network looks like. And it'll be a living entity. It'll be a living creature that we will be able to see all sorts of interesting insights. We will become the group that measures everything. We will test everything. And ultimately, we'll start building those kind of chaos monkey tools that will allow us to go out and really understand what happens if you actually bring down a piece of the network for a couple of minutes, or if you bring down a whole swath of providers or make them inaccessible for a couple of minutes. So now we're going to conclude here with one last major piece. And remember, renter-host protocol. We've talked now about the host. We've talked now a little bit about the network that's being fabricated together with all of those hosts. We've talked a little bit about how you're going to be able to access all that stuff together. This is the relayer. You have a customer with data on the left-hand side. They take that data and they feed it into whatever S3 tool that they're currently using. We currently have simple archival stuff up here, VM, Commvault, and Acronis, but it can really be any S3 application. We currently have an internal cloud we're using, and it's finally really starting to come together for us, called OwnCloud, and it's running on our network. We're going to be serving up all of our videos like these from our network here very shortly. We're currently in the process of a big website revamp across all our properties, and most of that stuff will ultimately get driven directly to our cloud. And so what happens is you send all that stuff up into the relayer through the S3 compatible interface. What happens then is that the relayer has a sophisticated onboard cache, and it has that database architecture we call the metadata database. And the metadata database has two functionalities. It has the standard metadata that we're all used to with cloud services, all the file attributes, versioning, and all of that sort of stuff. And the metadata pointing to the locations of all the data shards that live out there on the network. And they will recognize that having a relayer means they have data sovereignty. They own their data. And this is the tool that allows them to get that data onto the network. It is key technology. It works. We're extremely proud of it. And it is amazing. You upload into this cache. The cache will just slowly drain off into the network, and then, ultimately the data will stay in the cache if you need to keep accessing it until it gets evicted because you put more in the cache than the size of the cache. But we can take that cache and we can start splitting it up into special zones. We can make a zone in the cache that is a special immutability zone. And that zone would be great for what? Ransomware protection. You could upload into the special immutability zone, and then that would go off to special providers on the network where we just don't allow any access by any tool set to actually go out and grab or change that data at all. Every data piece on our network is immutable. When you upload a change to a spreadsheet on our network, you aren't actually changing segments. What you're changing is you're uploading a new piece of data to take over, and the old piece gets deprecated essentially. So with sophisticated versioning, you have this sort of ability of immutability with this special cache section going up to special providers that are marked for immutability. As ultimately you have complete protection to re-download your data and reinstitute your network and not have to pay all those bitcoins to people that live in some place thousands of miles away that you can't get to. So that's a big area that we're going to work with. We're going to have the ability to set up really large caches and set up caches that are able to bypass. So for instance, there might be a management cache, there might be an engineering cache, there might be a standard administration cache or sales and marketing cache. And each one might be set separately in terms of how much access and ability it gets to the network. Maybe engineering needs to have always the most performant access to the network, and administration and accounting and everybody else needs to have access, but it needs to be deprecated in terms of how it performs against engineering. We can do that. We can make that happen in cache. So the relayer has a lot of really cool iterations coming up in the future. And in addition, we're going to start releasing hardware-based relayers within the next 2 months. So there's going to be a lot of really fascinating development over the next 2 quarters with relayers. But the key take home from this presentation is the relayer works, and it's available today. And you can download and use it as a customer, and you can download and use it as a partner who's providing services to customers. Let me turn it back over to my friend Henry again, who's going to walk you through the relayer and show you what it looks like. And one of the quick things I will identify to you, notice how everything looks consistent. Our whole environment is consistent now across the board. So you're going to become familiar with one thing, and it's going to be very easy for you to find your way around any other tool inside our network. And we expect this to continue as we get more and more granular and more detailed and more feature rich and all of the things that are built into the tools. It's always going to be really easy for you to find your way bumping around this really convoluted, complex, and hard to fathom distributed data center, because we're going to make it really easy for you. Henry, take it away.
Yeah, that's exactly right. This is my favorite aspect of our network to show off. This is something that I originally I got to show off, or had the privilege of showing off at NAB in Las Vegas in April. But we've now since then come out with version 1.0. So this is a release version that everyone has the ability to download and set up and start utilizing. So this is the Relayer dashboard. So the Relayer itself, well, we're presented with a bunch of things here, but I'll start breaking it down in a way that makes the most sense to me anyway. The Relayer itself is actually a couple subsystems. So I think of the Relayer as a stack. There's a couple different components to it. We can see those are all active, and that's because our Relayer is already running. But if we wanted to shut it down gracefully or force start or force stop or give it a restart, we have those options on the side as well. And if we weren't already running, then obviously those would change to be started up instead. But since we're already running, and our provider, or our Relayer has had an opportunity to match with a bunch of providers, we can see that it's currently tracking about 2,400 providers across the network. And one thing that's really cool that I'll get into is provider profiles. So our Relayer is mapped to 2,400 providers, as we mentioned earlier. One thing that we have the ability to do is create provider profiles. So I made one here called Big Country, which is a bit of a silly premise, but it's just I want countries that are the biggest in the world, geography-wise anyway, and I only want to use providers in those countries. So you can see here, we can see how many different providers are in those areas, and then we can see how many are in a usable set that we've been matched with. So we can see of the 1,300 total, like 1,260 are matched to us. So if I go back to our dashboard, I can click Big Country, Set, and suddenly, we have that 1,200 providers, and this is what data would actually be uploaded to. But once again, those provider profiles are totally customizable, and we expect in future versions as well some pretty impressive ability for some pre-selected zones, and also as well some finer tuned controls for to what extent do we, filtering for providers based on certain performance factors. So uptime could be a thing, speed, how long the provider's been online. There's so much ability and power in order to filter providers for different aspects that you want to optimize for. And this is something that we're still in the early stages of actually presenting to the user, but under the hood, it is already very powerful today, and we would expect it to only be more so. So this is something that I think is going to be a very important aspect of optimizing your configuration and getting the most out of your Relayer. At the end of the day, so much comes out of parallelism and which providers are matched to. So that's a pretty neat thing. And you might also notice that we refer to data matched and parity matched as well. So if we hop over to this diagram, this is a kind of basic diagram. This is one that not only I made this, but I like using it to show off what makes our network a little bit different from the others. So if you're a little rusty on data and parity, essentially what happens, the original file is put into what's called a row. So the data row is just a section of the file, but then that data row is then transformed using erasure codes, as we alluded to earlier, to create parity sectors. And these data and parity sectors are distributed across the network. So the original implementation of this, and the one that the renter host protocol initially had, is that you would be matched to a certain number of providers, and each provider itself would have either a full parity copy or a full data copy. But what we innovated with our approach in order to lean into that parallelism is that we much more rapidly disperse these data and parity pieces. So some providers might only have one piece, some might have two, or I mean, it really depends on the specifics. But the idea is that we much more aggressively distribute these shards so that you are able to utilize a much wider number of providers, so you gain that parallelism of bandwidth for both uploading and downloading. And it means that in the old distribution, if you lost a provider, you were losing a full copy of parity or data, which was a pretty significant event. And I mean, obviously, there's still a large amount of redundancy built in, but when you already only have this lower amount of providers, losing each one stings a bit more. But when you have this much wider distribution, you're really able to benefit from the parallelism and the volatility up and down of gaining or losing providers doesn't sting nearly as much, and it doesn't affect your work nearly as much either. So that's the data and parity match. That's the significance of it. One thing I would also like to point out is there's room for, as well in future versions, one thing that I think we're expecting to be able to do is to match different providers for data and different providers for parity. So there's so much room for optimization around how you tap into your provider set. So for example, the data providers you might want a higher filter for, or a more performant group that might be more exclusive, I suppose. And then parity, you might have a little bit looser, and you might actually want distributed wider, because the idea is you pull from your data pieces first, and then if some of those aren't available necessarily, then you go out to the parity. So there's just a lot of room for optimization and improvement, and things are already working very well today. And it's just still so exciting to me how much further we can take these things. And this is really like unmapped ground in terms of like nobody else is really doing what we're doing and taking things this far and maturing them how we are. So I'm really proud to be able to show this off. So this is our dashboard and the configuration tab as well. Here we're kind of getting into the guts of the relayer. So we have some different general stuff. We have our database configuration. So I think we used the word database enough earlier, so I won't lean on that word too hard. But at the end of the day, there is some internal functions of the relayer that it needs a database for. So it comes bundled with one, but if you wanted to use an external database or have one that you stand up yourself or have some special considerations for, you're fully able to do that as well as backup and restore functionality for that metadata. There's also host IO. This is one that if you actually go through the process of setting up your own relayer, this tab will be your friend. So this is where you decide things like the size of your cache. So in this case, this is 900 gigs. I think in the dashboard earlier, it showed up a little bit larger. That's just because some, it's like gigabytes versus gigabytes or whatever. We don't need to get into that, but this is also where you choose the amount of data and parity providers that you want. So in this case, we did a 1020 configuration. So this would provide 3x redundancy, or I guess 2x redundancy, but 3x total. But this number, I mean, you could easily 10x both of those and have 100, 200, and really go wide. In fact, there's a lot of advantages to doing that. It's just on this particular example, that's what we went with. You can even choose things like, simultaneous uploads. So how many providers do I want to be uploading to at once? If you're on a more limited bandwidth line, there's reasons why you would want to lower that number. So you're not totally bottlenecked as you're trying to upload to like 10,000 providers at once. But we've got a pretty good networking on this machine. So anyway, I won't bore you with the rest of the configuration tabs, but there are a couple more as well. If I head back over to dashboard, now I'm going to take you through more how do you actually use the relayer, what's the significance of it. So Minio, as we've alluded to a couple times earlier, if we click on it, it'll just take us to our Minio browser. So this is where we can actually see the buckets that our relayer is hosting. So the relayer, the whole idea of it, right, is that it's a accessible cloud network. So we use the S3 protocol. The advantage of this is that there's already thousands of apps that are out there today that people like and use and already have workflows for, and they get to keep using those because we're not trying to reinvent the wheel. We definitely learned from and even make fun of other cryptos that make the mistake of trying to totally create their own thing, and they put a bunch of time and effort into it and then wind up abandoning it, and 6 months later it's forgotten about. We've seen that cycle so many times that we just didn't think it made sense on any level. So we went with the protocol that everyone already uses and likes, the S3 protocol, which is pretty much the de facto application protocol in data storage. So we have these S3 buckets available. We can see some sample files within them. We have Duplicati open. So this is just one of many S3 applications you could use, but just to show how easy it is to use the relayer. We have our backup section. If I go to configuration, destination, it's as easy as picking S3 protocol, giving it that endpoint. This is just localhost because the relayer is running on the same machine, but it could be a remote URL as well. And then plugging in the credentials that you configure. So here I can go to like test connection, and connection worked. So it's Duplicati's able to use it. I'm able to use this for backups, and they show up in the Duplicati bucket. They're not very pretty looking, but that's because this is the internal workings of a backup. So you're not really meant to be navigating this, but if you want to, you can see it. And I'm pretty excited to be able to demonstrate and show you that it works and it does everything that you would expect it to. I believe there's also a system view, so we can see some information about our relayer setup. So we can see like the memory and the processor that we have installed. So there's a couple different ways to deploy a relayer. So this is installed on Windows. There is also a Linux install, which uses Docker. So from that, you're able to kind of see some info about that as well. And drives. So in this case, on this machine, we don't have a particularly special drive configuration, but for a lot of people, it would make sense to have one drive specifically for your cache, or if you have multiple types of cache going, then it would make a lot of sense to be able to allocate specifically cache to different drives, that sort of thing. So just taking us back to the dashboard, I think we've now covered almost everything there is to see here. We can see, we don't have any pending uploads. That's because all the backups that have gone through this relayer have already gone out to the network. We can switch back to the default provider set, and that'll bring us back up. You can see the CPU usage, I think, will go up a bit, or maybe it already did. But yeah, we're back at our 2,400 providers that we're able to lean into and get the advantage of that really wide parallelism. And I mean, this row here, this could go way off screen to the right, because I mean, the legacy renter host protocol that we adapted from had a pretty standard 30 providers that it would use. And I mean, we regularly do in the hundreds or even thousands of providers for a large enough data set that you're able to utilize and gain the parallel bandwidth across. It's really impressive, and you're able to saturate and kind of gain advantage of some pretty big networking numbers. So I believe this machine we're on here is about 2.5 gigabit networked, but we've seen examples of, and we're in the future going to publicize some test results of going 5 to 10 gigabit and beyond. And we've already seen some early results that show that we're able to actually utilize and tap into a network pipe that is that big, which I think is something that is pretty awesome. And it shows a level of self-determinism, and then that it's your own infrastructure that begins to be the bottleneck at that point, and you're not waiting on some data center line that might be saturated and affected by other customers that are using it, like the classic noisy neighbor problem. And you're not stuck using whatever Amazon or whoever decides to allocate bandwidth-wise. It's up to you, and you can scale up or scale down however it makes sense for your use and your business. And this is something that I think is already a huge strength. And as we mature the process of host selection or provider selection and different ways to utilize like data match versus parity match, as we mature these processes even further, I think there's so much room for optimization, and it's already in an awesome place. So I think it's very exciting to get on board. And I'm very much looking forward to see how it looks in 6 months to 12 months, because it's only going to get better.
This presentation was built to sort of show the entire thing from start to finish. So now, if you have a circumstance that comes up and you want to tell somebody about our thing, that what you've been waiting for now for 4 years is finally real. And this is it. And we will continue to keep our heads down, doing the work and going forward. We really appreciate everybody tuning in, and we'll see you next week.